Yeah, g'day, Mark here. I've been working on making some tool holders for my lathe, and I've got to the point now where they need a whole bunch of holes drilled in them and tapped. And since I was given an Emuge, I think it's an Emuge automatic tapping head to go along with my Tapmatic, I figured this would be a great job to exercise both of them and see the differences between them. So now these tool holders need a bunch of threaded holes. These are M8, and then the little height adjustment mechanism is mounted with two M5s. I think I've got 12 tool holders. There's 5 holes in each of these, and a couple of others have got more. So I need to set up to drill and tap all of them. So I'll tap the big holes with this through tapping M8 tap. There's like a square drive here at the back, and then rubber collets clamp and guide the thing. These Tapmatics are great because there's like all sorts of sort of softness in this whole setup, so that slight misalignment or anything is not going to cause a problem. But for the M5 threads, I'll use this lovely little Emuge, not sure what it's called, tapping head. So I'll need to switch out the collet. Got a 6mm collet with it. They're these cute little ER11s. To hold that, I'll use the same tool holder I held this with. I own 2 machine tapping heads. My Tapmatic 70 I bought years ago, and this Emuge, which is much smaller and was generously donated to me by Christian, one of my Patreons. Now, automatic tapping heads are pretty darn cool, and as far as I can tell, the Emuge and the Tapmatic have basically the same system. When the tap's going in, the drive is locked between the input and the output, so you get a 1-to-1 rotation. Whatever RPM you set is what you get. The Tapmatic's got a little bit of give, but springy here, whereas the Emuge doesn't. It's rigid. Once you get to the bottom of the tapped hole, you start reversing out, which pulls up on this and disconnects the drive so it can freewheel. That's the same on both. And once you retract a bit further, a planetary gearbox engages, which reverses the direction of the tap and increases the speed. On the Tapmatic, that reversal is 1.75 times speed. I'm not actually sure what it is on this. I have seen some Emuges that say it's 4 times speed. During editing, I found a manual for this model, and it says to go a couple of % under feeding and a couple of % over 1 while feeding out. This means it must have a 1-to-1 gearbox on retraction, and that slight underfeeding is probably because it had a hard stop in the down direction, whereas the Tapmatic has that spring. Now, I really like these automatic tapping heads. They're kind of a thing for manual machines. Modern CNC machines have their spindle as a servo with position feedback. So like a lathe, they can coordinate the motion of the tap going in with its rotation. Now, my Mahu was built just a few years before that was a thing. So it's got a mechanical 18-speed gearbox and just a dumb motor. There's no angular feedback on the spindle showing its rotation angle, so you can't do those coordinated tapping moves. Mahu added that feature by switching out this and half of the gearbox with a servo motor on the E2 version of this mill. So that's why I have to use these automatic tapping heads for manual machines. It would be nice if I could get a shorter 25mm bore Weldon tool holder so I can mount this closer up to the spindle and save a bit of height. Mail time. Now this has come in from Willem. It's nice and heavy. Oh, it's gauge time. Very nice. Yeah, this is a beautiful little 2-micron reading MAR. Now this is a very interesting design. Got a 2-part base where this part sits on 3 points. The upper portion is attached with a flexure and sits on a single point. A couple of screws come in the back here through the flexure. Now this very nice chunky clamp comes over. A very nice accurate touch off. 2 microns is not much. And you could use this for measuring the accuracy of a surface. Boy, this really is lovely and accurate. So Willem, thanks very much. That's a beautiful stand and clock. This box of goodness then came in from Tim. He was watching one of my videos a couple of weeks ago and said he had a couple of bits and pieces which would help me out. So since the relay in my oven's a bit dodgy, a proper relay is a good idea. Oh, and what's this? Tools in boxes are always cool. Oh, that's really going to be handy. So I've already got a clock that I hope will fit. Cool. Oh no, that is a very nice bore gauge. Brilliant. But wait, there's more. It's like a present within a present. Now those are pretty handy because I've already got a few cutters that I didn't have arbors for. So this one's a 27, so that one I still don't have an arbor for, but there's a 22. Oh, okay, this arbor doesn't actually have a drive key on it. How's that for cute? Right, then there's some deburring bits and some taps. Yep, and then... Oh, that's brilliant, because that can be a replacement for the comically large one I've got here on my universal tool holder for the tool and cutter grinder. Nice slug of steel, and then end mills, and even more end mills. Wow. Oh, that's excellent timing. Some high pressure lubricant. This is the stuff you use for tapping. Since I've got a whole lot of tapping to do in this video, perfect. Ah, thread mills. This is what Tim originally contacted me about. I'm going to need to cut an M16 thread into the back of a tool holder, and thread milling is going to be the way to do it, to hold a pull stud. Thanks a lot for your generosity there, Tim. Oh, it's freezing in here now. We haven't had a temperature in Vienna for about 2 weeks that's been over freezing. So my garage is now cooled down to maybe 9 Celsius or so. So I just looked that up and it's about 50 Fahrenheit. Right, I just think I'll let this machine run at a low spindle speed and just move around a little bit with some circles just to get it a bit warmed up before I use it. Now my tool program was just all written by hand, and I've done this using a set of subroutines. The main program's at the end here, and the advantage of doing it like this is I can comment out any subroutine and therefore comment out any tool and run one tool over and over if I need to fine adjust things or anything like that. Now the interesting one would be the tapping here. With my tapping I've got a nested subroutine. First I set my Z target depth minus 27 millimeters from the top, and I set my RPM at 200 RPM. I wasn't quite sure what the ideal RPM is for tapping. Now luckily Tapmatic has actually got a speed chart they offer, so I'm cutting an M8 thread and I wasn't too sure what my alloy is, so I decided to be conservative and go for high strength steel and took 200 RPM. And then for the M5 I went for 300. To work out the feed rate, I've got feed rate being RPM times thread pitch. An M8 thread's got a 1.25 millimeter pitch. So that's to feed downwards. And then when I retract, I need to increase that speed by a further 1.75 times because that's the increased back gear speed of the Tapmatic. Yeah, for the Emuge, now what I now know is I should have reduced this by 0.98, slightly reduced the speed here, and that should have been 0.05 per the Emuge manual. Now I don't want to screw up one of my tool holders as a practice piece, so I'll just switch that out for a piece of bar that I can practice on, but that means I need to reset the Z height when I put this back in. Right, first up I'm just going to dry run this without any tools, just see what happens. I really don't think this machine likes this temperature. I'm guessing one of the spindle start relays is hung up. I shut the machine down when it had some dinner and let the machine think about its behavior while I was away, and it seems to be working again. So let's try this test piece. Oh, I need to fit the anti-rotation bar. Oops, forgot to video it, but it screws up in here. I think this is now going to work, so let's put in a tool holder, see if it really does. Right, quick sanity check on it. Certainly looks like it's roughly okay. Don't forget to reset the Z height mark. Now, one issue I didn't consider is that I can't leave this installed because it'll hit the vise. So I guess I'm going to have to do all the drilling first and then the tapping. I'll do one part complete first, but I think after this I'll just do all of the drilling on all of them because this position should be reasonably repeatable, and then I'll do all the tapping. Mail time. Bought this used. This is a light I already use quite a lot, and this one came up for sale for only 25 bucks in the classifieds. So if I get, perfect, get a second one of them. Realistically, how many 22mm deep holes in tool steel can you get out of a normal high-speed steel drill before it needs sharpening? Right, so I'd programmed those holes 19.5mm from this edge. So that's correctly placed, but, so what does it look like on a Schaublin one? Okay, that looks like probably more like 19 rather than 19.5. But what's the thickness? Just under 24. Aha, mine's 22. So with this thickness being two less, I'm going to need to move those 2mm over. Right, this is of course the bit that makes me most nervous, going 22mm in pretty hard steel with the Tapmatic. And for this I'm going to use some of the high pressure lubricant which Tim gave me. By the way, Tim's active on Instagram. I'll leave a link below in the video description. Go and check out his Instagram page, or feed, or whatever you call it. Right, well those settings look pretty good. I don't think I'm quite through yet. I set it to tap to 25mm, but you do lose a little bit of height at the start. Right, so it's very close. Probably only needs another millimeter or so. Probably not a great idea to re-enter a tapped hole with a Tapmatic, so I'll just do that last thread by hand and adjust the toolpath for next time. Still have to make up a set of those. Oh, that's good. That was the one I was worried about having clearance, but that's going to be fine. That's one down, 11 to go. Oh, you idiot. I don't believe it. I put the stupid part in upside down. Ah! Goes this way, of course. I think I bumped the button a second time with my finger. Bugger. The tip doesn't seem damaged. It's probably damaged my table again. Just realized that I didn't plan this job very efficiently. The three styles of tool holder are actually identical through here. Unfortunately, I made this my reference corner. So all of my measurements are based off that location. Therefore, I'm going to have to reset all of those locations for those points. If I'd planned it better and set that as my reference location here, and then set all of the parts into the vise with that 0, I could have at least got all of these holes done with the same toolpaths, leaving just a few extras. Right, next comes tapping, so I'll just go through and put some high pressure lubricant in all of the holes. Right, with all the drilling done, I can go through and comment out all those lines and activate the tapping lines. Right, well, unfortunately, having not thought through the correct 0 position for these parts, I've run out of time to do the 4 specials. I'll have to do them after editing this video. This one's, yeah. And I'm also going to need to make up a set of these adjuster blocks for them. Well, once that one relay in the mill started playing along, I'm quite happy with how these all came out. Both the Emuge and the Tapmatic seem to do a good job. I didn't break any taps. Obviously, the Tapmatic's designed for much larger taps. This one's designed for a range of M2 to M7, and this one M5 to 18, so they complement each other really well. I really would like to find a much lower profile 25mm Weldon 40 taper tool holder to be able to save a bit of vertical height on this. But all in all, they both went really well and complement each other nicely. So I'm out of time for this week, but before I go, just like to point out that I'm doing a Patreon and members live stream pretty much straight after this video. So stick around. I'd love to see you there. Thanks a lot for watching.